In the beginning, there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. In the deep nothingness of space, the cosmic silence is broken.
Space is actually kind of a noisy place.
Galaxies, stars, planets, and moons sing out with strange and alien music.
They sound a little bit like an alien fax.
Now, the Cosmic Playlist in a Top 10 countdown. The greatest hits of the universe. In a symphony of alien sounds. In space, no one can hear you scream. As the promo line for Ridley Scott's science fiction film Alien, it was designed to send chills down your spine. It's based on the unsettling idea that space is a vacuum, and sounds, whether screams, shouts, or songs, can't travel in a vacuum. But is that really true?
Well, it's kind of narrow to think that in space you can't hear anyone scream, because in fact, here on Earth, there are lots of sounds we can't hear. They're either too high a pitch or too low a pitch. Moreover, space isn't completely empty. And then finally, you know, what's the definition of space? If I'm an astronaut on the surface of Mars and I have a spacesuit on, am I in space or am I not? Well, I would think I am.
Okay, let's try right over here.
Back on Earth, Bruce Betts of the Planetary Society in Pasadena, California, has given a lot of thought to Mars and the subject of sound. He's programmed his computer with what he calls the Marsinator to demonstrate what his voice would sound like in the cold carbon dioxide atmosphere of Mars without those spacesuits.
The atmosphere of Mars would actually change your voice so it sounded deeper. So let's go ahead and simulate that using the Marsinator. And I will record my voice, and then we will shift it to what it would sound like on Mars. This is what I'd sound like on Mars, although I'd be wishing I had some oxygen to breathe. Then I go ahead and process it, put it through the Marsinator, and then we play it back and see what it sounds like.
This is how I would sound on Mars, although I'd be wishing I had some oxygen to breathe.
Of course, if humans ever do make it to Mars, we will not hear their voices through the atmosphere. Instead, we'll get them via radio waves, the way many of our most important sounds already reach us.
Yes.
We're familiar with thinking of sound as something that comes through the air to us, just like we hear each other when we're talking. But in fact, a lot of the sounds that we hear are transmitted through electromagnetic signals. For example, your television actually transmits a television signal into sound that you can hear.
Who's our first contestant tonight?
Sound in the cosmos will never reach us directly across empty space. So radio, light, or other electromagnetic waves are the inevitable carriers, bringing us a universe we can hear in all its variety.
Space is actually kind of a noisy place. It has many, many sources of noise that we are able to detect with special radio telescopes, for example.
These alien sounds make up an incredible collection, the ultimate playlist. We've polled our expert panel of scientists, astronomers, and physicists to rank the top 10. The greatest sounds from the expanse of space, ending with a number 1 that will surprise us all. And now, the countdown starts. Coming in at number 10, ringing out from a distance of 13 billion light years, the birth cry of the universe in a hit called The Audio Afterglow of the Big Bang.
It's remarkable that the young universe actually made a sound, and the reason we know that is that we can actually witness the glowing gases that were present at that time.
The glow from these gases is known as the cosmic microwave background radiation, or CMBR. It is a faint trace of microwaves that stretches across every point in the sky. Discovered by scientists in the mid-19th. The radiation is the afterglow of the Big Bang. The famous blotchy satellite map of the CMBR represents the cosmos in its infancy, when it was only 380,000 years old.
When we look at the CMBR map, we're essentially looking at a voice print of the early universe, because those tiny variations in color correspond to variations in temperature, and those correspond to variations in density and pressure. Well, pressure waves are just sound waves, so we're seeing little variations in pressure, little sound waves in the early universe.
To understand the audio afterglow of the Big Bang, we need to know how the early universe varied its pressures to generate sound waves. To find out, astronomer Mark Whittle and organ builder Manuel Rosales visit the magnificent pipe organ at Claremont United Church of Christ in California. In a way, the 4,000 pipes in this organ are comparable to the voice of the early universe.
Manuel, the amazing thing about the early universe is that all its pipes were sounding together. And it'd be lovely if we could just try that with this organ. So do you think we could do that now, play all the notes at once?
Yes. Let's pull out all the stops and try it.
Ah, that's where that phrase comes from.
Yes.
Okay, let's go. Very powerful, but really hissy, white noise kind of sound. But an even more remarkable thing about the primordial sound is that, in fact, a few particular tones were present and were stronger at any given time.
This is the opening note of hit number 10, the audio afterglow of the Big Bang. A computer sound analyzer reveals its strong tones as distinct columns on a color-coded graph. As hissy as the early cosmic sound is, it differs from pure white noise, which has no organized features at all on the analyzer. The sound of the audio afterglow, on the other hand, comes through with a vaguely musical quality. The pipes of this or any organ are made of wood and metal, but the pipes of the early universe were pits of dark matter, the mysterious substance whose existence is known only from its gravity.
What drives the sound waves is gravity. So, for example, if there's a region of slightly higher density of dark matter, there's a gravitational force pulling in. Gas that's surrounding this region feels that pull and it falls in, but it's gas, so it also, as it falls in, it compresses. That compression acts like a spring, and so it pushes the gas back out. But then it overshoots until it falls back in again. And this is how the motion of the gas falls in, bounces out, falls in, bounces out. So we have an oscillating pressure wave, a sound wave.
The cosmic background radiation, as important as it is just a still picture. its imprint of sound has the effect of no more than one noisy, barely musical note. And even hearing that is a struggle. The pipe organ helps show us why.
The sounds of the universe are way too low for us to hear. In fact, what's the lowest note that this organ plays?
It is a pipe 32 feet long, and it can only be played with one's foot.
Yeah, that's pretty deep. 32 feet were nothing compared to the cosmic organ pipes. They were between 20,000 and 400,000 light years across.
Sorry, we don't have any pipes quite that long.
No.
The deep sound of the early universe is so low, we can hear it only after a massive shift upward. The background radiation of the universe dates from 380,000 years after its creation. But what happened before that? Is it possible to uncover the whole song of the universe from the very instant of the Big Bang? The cosmos is filled with a symphony of alien sounds, and we're counting down the top 10 of the universe's greatest hits. Number 10 on the playlist sings out with the earliest tones of the universe, from the audio afterglow of the Big Bang. But our download of the universe's birth song has some problems. With the cosmic organ playing all its pipes at once, what reaches our ears sounds like only one complex, noisy note. It's only one note because it comes from the pressure waves we read from the map of the cosmic background radiation, which is just a still picture of the sound in the early universe, taken 380,000 years after its birth. How then do we run the clock backwards and hear the rest of the song?
Modern cosmology is sufficiently advanced that it's possible to create a computer replication, a simulation of the young universe. It's possible to recreate within a computer what's going on and how the sound developed right from the very, very beginning through those first 400,000 years.
They are the same kind of supercomputer simulations that have given us pictures showing how the early universe evolved. The dark matter pipes of the early universe acted like those in the church organ. As bigger pipes were played, deeper notes were sounded. As the universe expanded, there was more space and more time. More space meant bigger pipes, so the notes in the song got lower and lower as the song played out. Put it all together, and the first 400,000 years of the universe can be condensed down to just 10 seconds. A haunting primal scream.
The gas that's falling in and out of these dark matter regions is ultimately going to become the first stars, the first galaxies, and ultimately it'll be corralled into the thousands of galaxies that we see around us today. So while it's been amusing, really, and playful to reproduce these sounds for us to listen to, in the big picture, they play an enormously important role in crafting the structure of the universe that's going to unfold and the universe that we find ourselves in today.
From the big band sound of the Big Bang, our countdown takes a step down in size to the modest 15 million light-year span of a galaxy cluster. Coming in at number 9 on our list of the universe's top 10 hits is The Deep Tone of Perseus. This is low sound to the extreme, emanating from the Perseus cluster, a grouping of roughly 1,000 galaxies, 250 million light-years from Earth.
The central galaxy in this cluster of galaxies has a huge supermassive black hole at its center.
The cluster's central galaxy is called Perseus A, and its supermassive black hole gives it what's called an active galactic nucleus, which shoots out energy in the form of gigantic jets, tearing into the surrounding space.
For reasons which we don't fully understand, it seems to be coming out, the energy is being produced episodically, about every 10 million years or so.
Those energy pulses are actually waves of pressure, and that's exactly what sound waves are. Pressure waves. The wave, as demonstrated by sports fans, has an up and down motion that's very familiar to us. But these UC Berkeley students will switch gears and show us how a sound wave is different.
Okay, everyone, lose the pom-poms. Since sound waves are pressure waves, we're going to build a pressure wave out of all these students. Okay, everybody, let's line up. You go over here and then shoulder to shoulder, just like this, stretch out over there a little bit. No gaps. You're going to be students colliding with each other like molecules colliding in a sound wave. That's looking a lot better. Do you feel like a bunch of molecules? Okay, this is looking good. We have a bass drum at each end of the line. You'll see why in a minute. We'll get things going with this drummer over here. He's going to hit the drum and watch what happens. In this case, the pressure is a good, healthy shove, and it moves from student to student all the way down the line. At the end, the last student applies his pressure to the second drum by banging on it. This second drum is like our eardrum. When pressure from a sound wave in the air hits our eardrums, we hear the sound. This is just how sound travels through the air, except instead of having students shoving each other, there are air molecules shoving each other. A sound needs a medium to travel through. It can't travel through a vacuum. So in fact, to get from point A to point B, you need air molecules hitting each other. That's how it works.
So how do those pressure waves from number 9's deep tones of Perseus travel through what's essentially the vacuum of intergalactic space? Astrophysicist Richard Pogge of Ohio State University gives us a sense of the emptiness in deep space at his school's football stadium.
Well, it's true that sound waves can't travel through the vacuum of space. Space is not a complete vacuum. I'm here in Ohio Stadium, home of the Buckeyes. It's very empty today. I'm the only one here, and can't think of a better place to illustrate the vacuum of space.
The empty stadium can be a stand-in for the vacuum of space if we compare it with what it looks like on game day. With more than 102,000 people in its seats, Ohio Stadium would be like the atmosphere on Earth, jam-packed with air molecules.
So how much do we have to clear out this stadium to equal the vacuum of space? Believe it or not, you have to clear out everybody, including me, and then even I'm too much.
No more than a single cell from Pogge's body could remain in Ohio Stadium to come close to the vacuum of deep space. With what seems like almost nothing in the expanse between galaxies of the Perseus cluster, the existence of sound waves seems all the more incredible.
How do you propagate a sound wave through empty space when it's mostly empty? Let's use the example of me running down the field. I have to run a long ways before I encounter somebody, but I still encounter somebody and I can pass energy along to them. The same is true of atoms in interstellar space. It has to travel a long ways, maybe 300 light years before it encounters another particle, but when it encounters it, it passes the energy and the wave moves along.
The colliding particles in the Perseus cluster also emit faint X-rays, whose traces, imaged by the Chandra Space Telescope, tell us the waves are there. But these waves are huge, and the notes they produce are lower than anything any human has ever experienced.
The pitch is about 57 octaves below our hearing, below the middle of a piano range, and that actually qualifies this for the Guinness Book of Records as the deepest pitch known to man.
The extreme deep note emanating from Perseus is so far below our hearing range that it can only be approximated. It's been said the galaxy cluster is playing an awesomely low B-flat, and scientists calculate it'll be playing constantly for 2.5 billion years. Number 9's Deep Tone of Perseus drones on as the countdown advances. A secret number 1 waits at the end of the line, but first, a strange high-pitched squeal hints at what comes in at number 8. Sounds from space, and they're linked to signals from extraterrestrials. Starting with the Big Bang, we've been tracking the top 10 of the universe's greatest hits. The best of the alien sounds from space. Jumping to number 8 on the countdown, we find a sudden wide variety of different sounds. Clicks, whines, and screeches, all coming from strange stars singing out from everywhere we look in the galaxy. They're cosmic squeals with a rhythm section in the beat of the pulsars. Every pulsar has a different sound, but they are all related because they're repeating blips, beating out regular rhythms. The different sounds come from beats sounding out at different speeds. The first pulsars to be detected emitted radio waves so regular that astronomers first thought they were signals from aliens. But the truth about them was quickly discovered.
A pulsar is a rapidly rotating neutron star. That's a very dense star, and it's got 2 beams of radiation coming out the poles. As those beams rotate and intersect our line of sight, we see a series of pulses. We can think of pulsars being associated with sound because they were first discovered with radio telescopes. There was a series of beeps that radio telescopes detected. For a slowly rotating pulsar, you might have a series of beats like a metronome. Beep, 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 beep. Or you might hear a beep, 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 beep. Now, for a rapidly rotating pulsar, the beeps blur together, so you get like that. And for a very rapidly rotating pulsar, it's just a continuous sound that registers like a note in your ears.
Pulsars form from the collapse of very massive stars after they explode as supernovas. But how long does it actually take for a massive star to collapse? That's what Sherman D. of Tampa, Florida wanted to ask the universe when he texted his question to us.
Sherman, the visible effects of a supernova can last for months or years, or even centuries if you're looking at the supernova remnant, the expanding gases. But although it may seem incredible, the collapse of the core of a massive star can take just a second or two, and that's what initiates the supernova explosion.
Our own sun isn't massive enough to go supernova, but it is a giant ball of hydrogen, 330,000 times more massive than the Earth and burning by nuclear fusion. So our home star can hardly keep quiet, as our next hit proves. This hot combo chimes in at number 7 on the countdown. Here it is, the Song of the Sun.
The sun makes sounds, but they're not really sunny sounds. They're not happy sounds. They're kind of low, ominous roars that gurgle along. The sun makes sounds because there are a bunch of gases going up and down through a process called convection. So they're sending pressure waves through the ball of gas that is the sun, and it kind of rings like a bell.
Unlike a bell, the sun rings with 10 million different tones at once. We detect them from the tiny bulges from the pressure waves on the sun's surface. Solar satellites measure the height of the bulges with exquisite accuracy. Apart from sound, they also produce science.
So using these sounds from the sun that we can observe, we can actually tell very detailed things about the interior structure of our star. For example, one of the amazing things that we can tell is when there's a sunspot group on the other side of the star, even before it comes around the limb and we're able to see it with our optical telescopes.
The sun may be the biggest source for sound in the solar system, but next in line is Jupiter. So coming in at number 6 in the top 10 is a medley of strange electronic jazz from Jupiter. Jazz from Jupiter comes to us courtesy of the 2 legendary Voyager spacecraft, now on their epic journey to the edge of the solar system.
The 2 Voyager spacecraft are headed for interstellar space. They're on the very outer edges of the bubble the sun creates around itself. Today, Voyager 1 is 118 times as far from the sun as the Earth is, almost 4 times as far from the sun as Neptune is.
Project scientist Ed Stone has been heading the Voyager mission since its 2 spacecraft made their grand tour of the outer planets beginning in 1979. On their approach to Jupiter, the first thing each one encountered was the giant planet's bow shock, producing a wind-like sound from the electronic data.
There's a wind blowing outward from the sun at about 1,000,000 miles per hour. It is supersonic. As that wind approaches contact with a magnetic field around, say, Jupiter, it has to go subsonic. There is a sonic shock which forms in front of the magnetic field of Jupiter. That's called the bow shock. It's very much like a sonic shock in front of a supersonic aircraft.
More intriguing than the bow shock is the Jovian chorus, sounding something like the chorus of birds chirping at dawn. Both it and the bow shock come from radio waves generated by fast-moving charged particles within the bubble of Jupiter's magnetic field. Now, the scramble toward the mysterious number 1 in the top 10 swings to the moons of Jupiter and the rings of Saturn, where the noises from electric loops, glowing gases, and streams of wind vie for distinction as the spookiest sounds in the solar system. The top 10 countdown in the alien sounds of the universe has reached Jupiter, sending out its own brand of space music. But the next hit is no solo. Jupiter has a backup group. They're the Jovian moons circling the giant planet. And now they have their own album. It places at number 5 in the top 10, and the tune is called Moons Over Jupiter. The lead singer is the moon Ganymede, recorded by the Galileo spacecraft, arriving at Jupiter in late 1995.
The sounds that Galileo sent back from Jupiter's moon Ganymede, by the way, the largest moon in the solar system, are very intriguing. They sound a little bit like an alien fax. In fact, when I played that sound clip in my office yesterday, people came around the corners to see what was going on, if I was receiving some alien transmission.
As with Voyager, Galileo's sounds came from ionized gas, or plasma. Atoms in a plasma are split apart into negative electrons and positive atomic nuclei. In other words, charged particles. Two slender antennas on the spacecraft's plasma wave instrument picked up the radio waves that the charged particles produced as they were set in motion by a magnetic field.
These sounds that we hear from Ganymede are the evidence that Ganymede actually has a magnetic field. And you cannot find that information without using the plasma wave instrument, as we did on Galileo.
A very sudden burst of alien sound came from another of Jupiter's moons. It happened when Galileo flew over Io's north pole.
My favorite moon in the solar system is Jupiter's moon Io. It looks a lot like a pizza. This is the most volcanically active moon in the entire solar system, 10 or 100 times more volcanically active than the Earth. It literally spews tons of material into space every second, sulfur and oxygen atoms. These get ionized in Jupiter's magnetic field and actually connect back to Jupiter, to the north and south poles, making a donut.
The donut is called the Io flux tube, and the charged particles carry a monster electric current between Jupiter and its volcanic moon. As Galileo flew through it, the sound ended as abruptly as it started. With Jupiter and its moons finishing their acts, our countdown swings to Saturn, smaller than Jupiter, but right up there in the top 10. The ringed planet comes in at number 4 on the list. Listen up for the surreal sounds of Saturn. They come to us from the Cassini spacecraft, which has been delivering mind-blowing pictures and data since its arrival at the ringed planet in 2004. As on Voyager and Galileo, Cassini's plasma wave instrument is our proxy for human ears in space.
The eerie and bizarre sounds we hear from Cassini's radio and plasma wave instrument make me think of Halloween. They're due to the aurora on Saturn, very similar to Earth's aurora. Your ears could never pick up these frequencies, but we move them into a range. And when we do, we were surprised to see how eerie and scary they actually were.
The surreal sounds of Saturn isn't the ringed planet's only song on the countdown. Turn it over and we find number 3 on the playlist, Saturn's Flip Side. Scientists call this hit a crossover. This crossover has nothing to do with mixing musical styles, but describes radio waves from Saturn's northern and southern hemispheres as they actually crisscross in frequency over a period of time.
We saw something really strange in our radio data, in our plasma wave data, a couple of crossing frequencies that apparently suggested that the northern and southern hemispheres were rotating at different rates. That's very unfamiliar to us on a solid Earth, where the Earth rotates at one rate. It actually turns out we don't think Saturn's rotating at different rates. We think that high-altitude zonal winds are tricking us and making us think that there's different rotation in the northern and southern hemisphere, but it's probably not the case.
Similar waves following the lines of Saturn's magnetic field revealed a surprise about the ringed planet.
One of the most bizarre things that Cassini found was apparently the Saturn day was about 6 minutes longer than it was back in the days of Voyager, mere decades earlier. The determination of the length of Saturn's day is actually not possible by watching the clouds rotate around the planet. We have to use these radio emissions, the sounds of space, to see what the deep interior is doing. And that's where we found this mystery.
It's virtually impossible to slow down a planet the size of Saturn that much in such a short time. So scientists now realize the radio emissions probably don't give an accurate picture. And by sophisticated mapping of Saturn's winds, they now have a better take on Saturn's day, which happens to be 10 hours, 34 minutes, and 13 seconds long. Now, we're closing in on the surface of Titan, Saturn's biggest moon, as it swings into the Alien Sounds countdown. Hit number 2 rings out as Totally Titan. And it opens with an otherworldly hiss from an actual microphone on the Huygens lander, separated from Cassini and parachuting through Titan's methane atmosphere, nearly 1 billion miles away from Earth.
If you're parachuting, you're going to hear. That's exactly what we hear in these Huygens sounds.
The sound was transmitted as the lander headed toward Titan's surface in 2005.
The acoustic sensor on Huygens was essentially a microphone, but it only sampled every couple seconds. It would take a little sound, tiny, tiny sound bite, and then nothing, and then a tiny, tiny sound bite. It wasn't planned to turn that into sounds that the public could hear.
But unlike the other sounds from Saturn, these were not converted from radio waves. They began as true sound waves in Titan's methane atmosphere. And the Planetary Society stepped in to convert the staccato sampling of the microphone into something audible to human ears.
In the end, what you hear is mostly wind noise as the parachute's descending through the atmosphere, and then things get much, much quieter on the surface. It goes from to suddenly being. But what's really profound is we're hearing sounds taken by an actual acoustic sensor from 1 billion miles away. First time we've ever heard sounds from another planet or moon around another planet.
But the rushing wind wasn't the only sound coming from Huygens. As data streamed in from the lander on the way to Titan's surface, white-knuckled engineers in mission control held their breath, hoping the intrepid spacecraft would make its landing safely. The final chapter in the story is told in an incredible music video, guaranteed to keep you on the edge of your seat. We've been counting down the top 10 alien sounds of the universe, and we've almost reached number 1. But first, we're shifting into high gear, as number 2 runs with an astronomical riff from the Huygens space probe visiting Saturn's largest moon, Titan. It's the only alien sound that comes with its own music video. Look and listen. Cut 2 on number 2. It's Totally Titan.
Here we have what's called the Bells and Whistles movie from Cassini-Huygens, and it's showing the descent. And it's a great example of using sound to convey all sorts of different kinds of data.
Just as a Geiger counter announces radioactivity using audible clicks, the instruments on the Huygens lander were given their own sounds to register the measurements they were taking.
Those chimes you hear, each one of those means that an instrument was taking a picture or some other kind of data. Different instruments are a different chime. We also are hearing kind of a hum in the background that's the signal strength to the Cassini spacecraft. We've got a ticking that occurs that has to do with the spinning and rotation of the spacecraft. Every time it rotates once, they have the tick.
Though it's just an assembly of pure scientific information, the video seems to preserve what must have been those last moments of high tension. When the scientists in Mission Control wondered, will the tiny spacecraft land safely, or will it crash?
So here we go, and almost down. And then we're landed.
Mission accomplished. With sound 1 billion miles away. Totally Titan has been a thrill at number 2 on the countdown. But now we spin the platter on the mysterious number 1. A song that comes from a place totally unlike anything else in the universe we've ever encountered. While some remind us of the strange signals from Jupiter and Saturn, there are also sounds in this song that are completely different from anything we've measured or detected anywhere else in the cosmos. Because number 1 on the countdown has sounds alien to the entire universe, except with a place where they originate. Number 1 in the universe's greatest hits resounds with echoes of a singular place. The echoes of Earth.
Here on Earth, we're used to thinking of the alien sounds as being everything that comes from beyond our planet. And that might be examples of plasma waves and pressure moving through astrophysical media or objects. But really, if you think about observing our Earth from afar, the aliens are us. And our sounds are unique because they come from living organisms, whether it be human language or bird songs.
An alien probe exploring Earth space would certainly pick up the Jupiter or Saturn-like sounds of charged particles propelled by Earth's magnetic field. But our planet, unlike the others, also emits radio waves, broadcast into the cosmos by human beings.
Good evening. This is Professor Reginald A. Fessenden, speaking to you from Brant Rock, Massachusetts.
In 1906, at Brant Rock, Massachusetts, Reginald Fessenden made the first radio broadcast of speech and music. Fessenden was the inventor of AM radio, transmitting his first signals on Christmas Eve. It was picked up by sailors hundreds of miles out at sea, and has been traveling through space ever since.
Ever since the beginning of radio, we've really been broadcasting out into space. And we've been sending out these signals in the hopes that somebody will intercept them. Of course, space is a very large place, and therefore it's hard to know who would have gotten them and when. But there they are, on their way out to who knows where.
Hello from the children of planet Earth. Konnichiwa. O genki desu ka?
Earthly sounds are also traveling through space, not by radio, but aboard the 2 Voyager space probes, on a slow but steady course to the stars.
Bonjour tout le monde.
One of the examples of how important sound is to us here on Earth is that when we launched Voyager, we actually included a golden record of sounds from our Earth. And this was to represent not only human sound, but also sounds of the many creatures that live here on Earth with us. So it's really a sound fingerprint of life on our planet.
As we take our own place among the top 10 hits in our playlist, we realize they only scratch the surface of the cosmic voices calling out in the void. From creation to the present day, space has produced a broad catalog of sounds to accompany its brilliant sights. As strange as these many sounds seem, we've learned that they carry important messages, helping to solve mysteries of nature and our ultimate understanding of the universe.